Now we will be looking at our SQL architecture. Okay, so this will be at very high level. You have primary components here. The primary components for this high level architecture is you will have mainly three here, three layers. One is your protocol layer. Let me draw this. So one is your protocol layer, which will be from the client side. So where your this is going to facilitate your communication between client and the server. So from here you are going to connect it. So this is your client, and you are going to connect to the through the TDS protocol. Okay. So it is going to handle your request and results. This is what you will have a basic connectivity. So that will be our first layer. Then you will have something called Relational engine. Okay. So this will be our query processor. So whatever you are seeing it here, this will be your query processor. Once it comes from this, it is going to execute the queries here. Okay. So you have a CMD parser, which will receives the language event. This is your brain. So we call this as brain. So it will determine how to execute the request. Okay, it will take the request, it will execute how to execute this. Okay. So it will check the syntax, and then it will validate the request. Okay, it is going to check it. Okay, then it will validate. Okay. So then you have something called optimizer. Okay, analyze various ways to execute, how it can be executed, and it will select the most efficient query plan. Okay. Then you have a query executor. Okay. This will execute the chosen query plan by requesting the data from the storage engine. Okay. Now you give me the data. So this you are going in a storage engine now. Now you are into the storage engine. So this will pass on to the storage engine. This layer is responsible for managing all the data transactions, and then your memory as well. Okay. So you will have access methods. Okay. So how you are going to access this interface between query executor and your data transaction logs. So this will be having a your data transaction logs. Let me erase this. So here you will have query executor. Okay, between query executor and then your transaction logs and the data. Okay. So this is how it will be executing. Then here your data. So it will be determining how to retrieve or modify the data. Then you have something called buffer manager. Okay. Buffer manager is it will manages the movement of data. Okay, between the physical disk. Okay, and the memory. So how it will be managing that. And then it uses the data cache here. Data cache means it will include the plan cache and dirty pages. Okay, to improve the performance by creating a frequently accessed pages or frequently accessed in memory. Okay. So dirty pages is here, it is not really dirty. Okay. So dirty pages means which are accessed often. So the most accessed files are called as dirty pages. Okay. Then you have here transaction manager, okay, where it will ensure your ACID properties, okay, your atomicity, all these properties it is going to take, okay, your atomicity, then consistency, then isolation and durability, okay, by coordinating with transaction logs. Okay. So this is at the high level. Okay. Then you have data file here. Okay. This is the physical storage that you have it on the disk. Okay, where the actual data resides. So this is your where your data will be residing, the actual data. This is how your query will get generated. Now let's see how the transaction will happen. Generic transaction, how this is going to happen. Okay. Let's say a client is going to request it. So it will request a query. Okay. Now it will go to the protocol layer through SN. Okay. Then it will come to the brainy. Okay. So then CMD parser will validate the syntax. Okay. Then it will optimize what needs to be done, the efficient path to get into the query, whether you need to have a index, okay, or the full table. So it will optimize. Once it is optimized, it will generate a query. It will generate a query plan. So then it will now the execution, it will be in the hands. Okay, this is the execution. So now it will send it to the access method. See, I want the data. Okay, give me. Now it will check whether it is in the memory. Okay. If it is not in the data cache, it is not. Okay, then it will fetch us in the data. This is how it will be done. Okay. If the query needs to be modified, okay, then the transaction manager will transact in the log. Okay. If we want to write something, then this will go here. Okay. So this is how it will be finalized. Okay. So then it will give the result. Okay. Then it will be giving the result now. This is how a component interaction will occur. Now let's see what is the interaction between interaction between transaction manager and transaction log, and then the buffer manager. So we'll see what is this, how it will it is going to work. Okay. So the interaction between this manager, log manager, okay, and buffer manager is the core mechanism that balance the performance with the data safety. Okay. This concept is known as write ahead logging. So we call this as WA, okay, write ahead logging. Okay. This is how it works together to ensure that data isn't lost during the crash. Okay. If there is a crash, it should not be, the data should not lost. Okay, to keep the server running fast. It does not write the data change directly to the disk. Okay, here. Okay. So this is where your data. Once you write it on the data, then only it will be saved permanently. So what it will do is data file on disk. Okay, every transaction, it will not write it. Okay. Instead, what it does is it will do the modification in the buffer pool. Okay. So whatever it is in the sorry, this will be in the memory. Okay. It will modify it in the memory. Okay. So once this is memory, in memory chain, when you update a row, okay, buffer manager will modifies that particular page. Okay, in that memory, that page is now marked as dirty page. Okay, because it differs from what is currently in the disk. Okay, this is going to differ. The dirty page is differing whatever is in the memory, in the storage. Okay. Then a log rule before the system is allowed to write a dirty page. So there will be a log. Okay, if I want to write this to memory, okay, I am not going to write it directly. Okay, before memory to physical disk, okay, it must flush the corresponding logs here. The transaction log, I am going to place this transaction log, and then it is going to commit it on the disk. Okay, by this it will have a persistence. Okay, the transaction is log is appended only file, okay, which is extremely fast for disk to write. Okay, it will be extremely fast to write. Okay, once these logs are recorded, and it will be sent to the physical disk. Okay, then the transaction is considered as committed. Okay, so this is how it will be done. Okay, now you have let's say what happens on the during a crash. What happens during a crash? Okay, let's say if power has gone down. Okay, if the power goes out. Okay, then let me. So dirty pages in the memory are lost instantly. Okay. However, the database is safe because the transaction log, the database is safe because of this transaction log. Okay. So when in the recovery phase, the SQL Server restarts. Okay, then it will scan the transaction logs. Okay. Then a redo will be done. Okay, it identifies the transaction log that is committed the last time. Okay, but those changes had not yet been written from the buffer. Okay, from the buffer. Okay, it has not returned to the data file. Okay, it replays these actions to ensure that data is updated. So it will be a redo log will be done. Okay, from the buffer to the data file. Okay. So whatever present here, it will be returned into the data file so that it will be done. Okay. Then there will be something called undo. Okay. If there was a transaction in progress, okay, if there was a transaction in progress and it's not finished, okay. So when the crash occurred, the system rolls it back and it ensures that the database returns a consistent state. It will undo it and it will make, okay, there is a clean state now. So the database is not crashed. It will just undo it. Okay, the last transaction it will undo. So by separating the high speed, okay, and volatile memory operation, this is your volatile memory operation. Okay, buffer manager. Okay, this buffer manager. From the low speed, this is very low speed, okay, this is very high speed. Okay. There will be a persistent SQL log operation, that is your transaction logs. Okay. So this SQL servers achieve this ACID compliance without sacrificing the performance. Now we have something deep dive. Okay, this will focus on the complete system architecture and resource management. Okay. So earlier it will be what and this will be how. Okay, so you have resource management, and then we are introducing the SQLOS here. SQL Server Operating System. Okay. First diagram shows what happens to a query. Okay. The second diagram shows how the system manages the hardware resources like threads, then memory lock, and then your logs. This needs to actually perform those tasks. So the second diagram will explain you on the SQLOS layer and the abstraction layer between the SQL Server and the operating system. Okay, so this will give you the overview. This layer is what makes SQL Server so efficient, as it manages the resources itself rather than relying entirely on the host OS. Okay, which might not be optimized for database workloads. Okay. So let's see on the what are the SQLOS components. Okay, so you have first thread scheduler. Okay, instead of relying on Windows scheduler, okay, it has its own thread scheduler. Okay, then it will uses its own user mode scheduler, which we will call it as UMS. Okay, it will maps the task to worker thread efficiently to avoid a context switching overhead. Okay. Let me show this. So I will explain this. Okay, how the context switching will done. Then you have a memory manager, where it manages the memory allocation, including the buffer pool, okay, ensuring that the database engine has memory it needs without competing poorly with the other application. Okay, it will have its own buffer pool. Then you have IO manager, okay, input output manager, which will handle your physical disk reads and write in a way that prioritize database throughput. Okay. The worker nodes, worker threads, then your deadlock manager. So here in your worker threads, it will manage the deadlock monitor, lazy writer, etc. All these will be running in the background process. For example, the lazy writer is the cleaner that periodically cleans up the memory in the buffer pool. Okay. So whatever is in the buffer pool, it is going to clear it, frees up in the buffer pool by writing the dirty pages to the disk. Okay. So that will ensure that user queries don't have to wait for the memory to be cleared when they need to load the new data. Okay. So then we will have a first diagram is, okay, mostly on the functional and query. Okay. Let me go to the first diagram. It is not coming. So this will show how a request is processed. This is functional query. So the second diagram will show you the internal system, how the resources are managed, how the resources are scheduled. So this is the internal and resource management. Okay. This will be much more on SQLOS, then thread scheduling, then memory IO, okay, and then understanding the engine performance. Okay. So first one will be mostly on what we will be discussing. Second one will be, it is how you are doing, underlying the engine's management capability of compute and memory resources. And this is what we have in our documentation. So client application, then you have your ODBC or JDBC driver, then SNI, then on the Relational engine, where you are getting your query processor, and then you are doing it. After that, it is going to the storage engine, your buffer manager, everything. Once this is done, you are going to the physical disk. This is what we captured in our documentation. Okay, let's understand the ACID properties here. What exactly is the ACID properties? Okay, let's see the data integrity part. Okay, so SQL database is optimal choice for structured and reliable or a standardized way to manage the data. So let's say this is designed to prevent the data corruption. Okay, let's say they will be using primary key and the foreign key. So we have primary and a foreign key. So to ensure that the data remains accurate and consistent across all the system. Okay. Let's say you have a banking customer A. Okay, is transaction 2 lakh rupees to customer B. Okay. In between the transaction, okay, fails. Okay. If the customer B has not received this money, okay, then it has to go back to the customer A. Okay, the money cannot disappear like this. So this is what we call it as a integrity. Okay, if the system fails halfway, okay, the ACID properties needs to ensure that the transaction is rolled back. If they lost money, okay, let's say, so in between these two, the transaction got failed. Okay, then it has to roll back from this. If he has not received the money, okay, let's say it has not received, then this has to go back to the A account. This is called the ACID properties. Okay, that is why banks use this type of database. Now you have something called complex relationship. Okay, so when your data is highly interconnected, okay, SQL database allow you to link data tables together efficiently using the join. Okay, so example, in an e-commerce system you have customers, then orders, then products. Okay, then you will have a big inventory list. Okay, a single query can join all these tables to answer. Okay, which customers in Bangalore has purchased a specific brand of laptop in the last 15 days. Okay, so this will get the query easily. You can get that query. Okay, now we have something called compilance and audit trails. Okay. So the because SQL database are transaction heavy, they keep a detailed transaction logs. Okay, this is essential for industries that must prove who changed on what. Okay, example, in healthcare regulation like HIPAA, okay, that requires any change to patient's medical data should be logged. Whoever access that or change the record, it should be logged. An audit trail allows the administrator to see exactly which physician updated a prescription at what time. Okay, so this is with respect to the compilance. And then we have something called analytics. Okay, in analytics, for example, it will provide you a powerful and standardized language for aggregating and analyzing the data. It is the gold standard for business intelligence. Okay, so you get example, a manager can run a simple query, okay, to calculate year-on-year growth revenue. Okay, so he will just select year from sales, some sales from order, and it group by year. Okay, then this will perform a math and aggregation across massive data sets, and then it will give you that particular result. Okay, then we have something called tooling. Okay, so we have been SQL has been for over a decades now. Okay, it's almost 2 decades now. Okay, so there is an immense ecosystem and mature tools that make the development faster. Okay, and it is safer. You have ORM, okay, object relational mapping, and then you have automated backup. Okay, so developers often use this tool to like the entity framework or Hibernate, which allow them to write code in their favorite language, okay, favorite programming language like Python, C, and ORM automatically generate that particular complex SQL queries for them. So they write in Python and it will query it in SQL. So this is going to convert that. Okay. So this is how you will speed up the development time. Okay. Then we have automated backup. Okay, the structure is well defined. Okay, and we have robust and automated tools to create a point in time backup. Okay, allowing organizations to restore the database to the exact point. Okay, exact second before the catastrophic error that has occurred. Okay, so that is the reason why most people prefer to have it the SQL Server.